Well, I'm very pleased to be here. I'm going to talk about blockchain. Right. I'm going to talk about blockchain technology. I'm very pleased to be able to share this story with you, the young creators audience. If you look at the news, it's hard to miss all the hype about Bitcoin and blockchain, where blockchain is the technology behind Bitcoin. You see all the headlines, and you think, what's the hype about? You see a lot of talk about investments in the technology, developments going on in the technology, companies merging, all these things that are going on. So in this talk, I will explain what is blockchain, what are the benefits, how does blockchain work, what's the potential of the blockchain technology, and what are the current limitations, so that you will be able to distinguish the noise from the signal. I hope you people in the back that you can see there's a signal in this noise. Right. So for me to get an idea, who of you currently works with blockchain technology? No one. Right. Good. A lot to discuss then. One practical thing. There's 20 minutes and a lot I want to share with you. So if you have any questions, please save them till the end of the talk. In order to explain what is blockchain, let me start with an example. If you buy a used car, it's very important that you know, you need to determine the value of this car. One of the things that determine the value of this car is the maintenance history of your car. Has it been serviced by properly qualified people at the proper intervals? Have the right parts been used to service this car? Right now, you get a proof of the service history, which is a paper booklet with some stamps. You can hardly call that a proof. I mean, who says who put those stamps in? And who knows, maybe those stamps have been put in just before I arrived at the dealership to buy this car. This information, this maintenance history, it's also stored in a system, the administrative system of the garage. But that's a central place I cannot access. And also there, I cannot verify that what's in there has not been put in there just before I arrived. So how does this work? How would that work if blockchain would be used there? If blockchain would be used instead, I would know that all these messages, when has the car been serviced, these messages are signed by the private key of the mechanic that worked on the car. I know that it's stored immutably on the blockchain. I also know when these messages were put on the blockchain. So it's not 5 minutes before I entered the shop, but actually every year it has been maintained. The other thing is this information is available to everybody with access to that blockchain. So it's not just the dealership, but also the previous owner can verify that indeed these service that the car has been serviced at these times. And since it's stored in the blockchain, since it's stored in a distributed database, why not add other information as well, which is relevant to the value of the car? For instance, the number of previous owners, or large insurance claims, which relates to the car being damaged, or whether or not the car has been a rental car before. Other things that influence the value. So before we go further with how blockchain works, first I want to show you a short video.
At ING, we're committed to investigating the latest technological developments that could help our customers better manage their financial lives. One current area of interest is blockchain. At its core, a blockchain is simply a digital ledger with a full record of transactions, running on multiple computers that can be spread across the globe, but one where a transaction, once confirmed, can never be changed. We call this an immutable distributed ledger. This can be used to transfer anything of value, from money, bonds and titles of houses, to the execution of contracts and other possibilities currently being explored. To transfer value, a sender creates a digital message outlining the transaction, then broadcasts it to the entire network. All new transactions completed in a time frame are then bundled and permanently fused into a block, which is added to the end of the chain. But rather than be stored in one single location, a copy of the entire chain is deposited with all of the service's users, ensuring everyone always knows the latest status and that mistaken or fraudulent transactions are minimized. The most popular products currently using blockchain are digital currencies. If Bob wants to send an amount to Sue, he sends a message to the whole network informing them of his identity, Sue's, the amount, and a unique digital signature created by Bob's private key. Once everyone on the network verifies the validity of the transaction, the value is transferred, and the ledger or chain is updated everywhere. No middlemen, minimal delays, and minimal fees. So blockchain can host a currency or other financial asset, but it can also be used anywhere where a guaranteed chain of events or actions is important, tracking diamonds to ensure they are from legitimate mines, luxury goods to confirm they're not fakes, or organic food to show where it was grown. Additionally, blockchain can also contain a piece of code that checks if certain external conditions have been met before executing a contract, or automatically trigger an action to do so, such as checking with the post office to ensure goods have been received before releasing funds. For ING and its customers, one opportunity lies in asset transactions where it is essential to know who has owned the asset in the past, who owns it now, and whether they are free to sell it to a new buyer, such as the transfer of stocks, bonds, or real estate. By moving to a transparent blockchain approach, the existing layers of checks, costs, and delays necessary to confirm these points could potentially be reduced, ensuring these services can be offered more securely, efficiently, and cost-effectively. By continuing to investigate technologies such as blockchain, ING is underlining its commitment to empowering our customers and to helping them stay a step ahead.
Right, so if we sum this up, what is blockchain? It's a distributed ledger with cryptographic integrity. And obviously it's most famous for Bitcoin. Whenever I talk to people and I tell them I work with blockchain technology, people ask me questions about Bitcoin. And it makes sense. It's the most famous use case yet that's built with blockchain technology. But if there's one thing that I want you to remember from this talk, is that blockchain technology is not limited to Bitcoin or to payments or to the financial sector. These characteristics, it's a decentralized network, there's trust built in the technology, there's the consensus between the transactions, between the data on all the different nodes in the network, the immutable records. These characteristics, they're also useful in many other use cases. Right, so the core concepts you need to remember, it's distributed, it's immutable, and it's a ledger. And if you think, so that means that if you now have, now you often move data from one organization to the other. Whenever you cross the boundaries of an organization, you need to build interfaces to go from one data model to the other. Whereas if you use blockchain and you have a distributed database, everybody has the same model and the same view of the data. The trust is built in. Just think of Bitcoin. You do a payment to somebody you don't know, but still the trust is built in the technology. And the data is cryptographically signed. So if you just take a moment to think about what these characteristics mean for the systems that you work with in your daily life. It's very powerful. And if you need some inspiration, maybe it's good to have a look at the state of the dApps. It's a website which lists all the applications which are deployed on Ethereum, a popular blockchain platform. It's a multi-purpose blockchain platform. And if you look at these applications which are deployed there, it's all kind of different use cases. It ranges from peer-to-peer marketplaces, domain registrations, insurance, mortgages, gambling, social networks. There's a blockchain version of Uber. Basically everywhere where you benefit from a decentralized network, a decentralized database, and the trust between parties built in a technology, there you can apply blockchain. To explain why decentralization is so powerful, I use a payment example. Can't blame me, I work for a bank. The current situation is on the left, on your left, so the clearinghouse. There's a central party in between. If two banks do a payment, for instance, from ING to ABN AMRO, I pay to somebody with an ABN account from my ING account, and I pay him 10 euros, then somebody needs to keep track that the balance of ING goes down with 10 euros. Currently, that's done by a central party, a central system. But this central system, it causes single point of failure, it causes costs, and in this particular case, for euro payments, it's only open in office hours. So if you take that out and you replace it by blockchain technology, where you no longer need a central party to keep track that all the transactions are consistent, because it's built in the technology, then you eliminate all these disadvantages. And you have 24/7 instant payments. If you look at the Bitcoin model, it's more radical than this. There's no banks here. It's just everybody who wants to do a payment can get an address on the Bitcoin network. The reason, the advantage of this is that every payment goes through the bank, so the bank knows the identity of the person doing the payment. If you look at it conceptually, whenever a transaction is initiated, it's first signed. If you look at Bitcoin, the transaction is a payment. But if you look at the example of the maintenance history of a car that I started with, then it's the mechanic sending a message to the blockchain, yes, I served this car. Transaction is added to a block. The block is hashed, added to the chain, and is shared and broadcasted over the whole network. So some concepts. A block, it's a collection of transactions. The transaction, it contains the sender, receiver, and the information. And there's consensus in the network. The network reaches consensus on what is the truth, what is the current state of all the data in it. First generation of blockchain technology, it was single purpose. Multi-chain on which Bitcoin is built, it serves for payments. You can send some data, and it supports some instructions on the data, but that's very limited. Current generation of blockchain technology, you can look at it as a platform. Like a mobile phone, you can develop apps for all kinds of use cases. It's the same with the current, the latest generation of blockchain technology. For instance, in Bitcoin, you have proof of work and mining to get consensus. In the latest, the current generation, you can change that consensus mechanism, and also you can run software on it. Blocks and transactions, as I just said, a block contains a list of transactions, and important to know that it also contains a hash referring to the previous block. So if you want to change one of the transactions, you need to change the hash of that block and all the blocks afterwards. Smart contracts, a very important feature of blockchain technology. Basically, any piece of software that executes the terms of a contract is a smart contract. That's not new. That's invented in the 90s. But what makes it so powerful on blockchain technology is that you combine it with the trust. Blockchains can contain value, so if there's a payment required to be executed by this smart contract, it's very easy to integrate. And you have the transparency, so everybody knows what's going on, what's the current state of this use case. Ethereum, as I said, a very popular blockchain platform. It contains all the characteristics of a computer. You could basically look at it as a distributed computer. And you can run your smart contracts to create your business logic, and you can store your data by sending transactions to it. Blockchain technology currently has limitations. For all these limitations, solutions are being developed. For instance, scalability. Because everybody on a network has a copy of all the data and processes all the messages on that network, adding more computers to that network will not help. But there is, for instance, for the scalability, there's the sharding, which is a solution where everybody only processes part of the data and of the messages. Same for all the other limitations. There are developments to improve that. And even though there are current limitations, already with the current state of technology, a lot of value can be created with blockchain technology. And because there's so much development on these limitations, there's also a lot of potential in the technology. Actually, the situation that we're in right now, it reminds me of my first job. When I started working, I built web pages for mobile devices, for phones. But as you can probably judge, when I started working, it was quite a long time ago. Phones look like this. This was the Nokia 7110. It was the phone to have. And these applications, these internet applications on this phone, they were quite cumbersome. It was a small screen, small bandwidth. It was not touch screen. You had a scroll wheel to navigate through the menus. But everybody knew that being able to access the internet from your mobile phone, there was a lot of potential in that. And we all know what happened next. I mean, it took some generations of phones to improve, but everybody was right about the potential. We see the same potential in blockchain technology right now. And not only ING sees that. And there are many startups working with blockchain technologies. Many technology companies working with blockchain. And last but not least, a lot of money is invested in blockchain technology. I omitted 2016, but to date, end of May, over $1.1 billion is invested in blockchain technology. So I know many of you are serious about shaping the future, about building your dreams. And my advice to you is do that and do it with blockchain technology. That's it. Thank you.